in order to graph this function, we need to make a table of at least two good dots. So to make our table, I'm going to choose x and y values. All right. And what are the two values that would be good to plug in? Well, the best values when you're dealing with a log is to make what's inside the log 1 and the base. Those are your best two values. So we want inside the log to be a 1 and the base. Since the base is 5, that's what we're going to be wanting to choose. If you choose a 0, it'll error out. Negatives will error out. If I chose like 3, it would be a really weird decimal. It's hard to figure out. So we're going to plug 1 in. And then, oh, by the way, you're going to plug 1 in, find the value, and then do the opposite. So what we're saying here is we're going to do the opposite of whatever we get for both of these. Now, what's inside of each of these is this answer. So what I'm going to do here is I need to find log base 5, and in for x, I'm going to put 1 and 5. So I'm going to do this one, find the value, and I'm also going to do log base 5, and find the value. So I put 1 and 5 into the log, and then we'll take the negative at the end. So what is the answer to this? Well, when you see log 1 base 5, that's saying 5 to what power is 1? Well, 5 to what power is 1? That would be 0. So that's 0. So this is 0 here. This one, the other one right here, is saying 5 to what power is 5? So 5 to what power is 5? And that would be 1. Okay, so what do we have here? Well, the opposite of 0 is 0, and the opposite of 1 is negative 1. So we have two coordinates now. We have 1, 0, and 5, negative 1. So let's put those dots down. We have 1, 0, and 5, negative 1. Those are my two dots. Now, how does this graph look? Well, you have to remember, with logs, you have a vertical asymptote at the y-axis. All right, so my vertical asymptote is right there. So let's kind of draw that in best I can. It's just an asymptote. It means it's a line the graph will never cross or touch. And so asymptote, again, is what you will never touch. We're going up against. And you should know no values even exist over here because logs can't have negatives, nor can they have 0. So to draw this graph, it's going to go right up next to that. And then it's going to come, hit that, and keep going down like that. So that right there would be the graph of negative log base 5x. Remember, all have an asymptote right here unless it's shifted. Then your asymptote might move. Now, that next question, we forgot about this right here, but what interval have positive values? So looking at this graph, what interval has positive values? Well, I see positive values right here. See the graph right there? That graph right there is all positive values. And the interval for that is right here. The interval is between 0 and 1. So my answer here is between 0 and 1 is the interval for which I have positive values. So what interval do I have negative values? That would be from 1 to infinity, forever. There's no values out here. Now for this next graph, I want to graph this one. So let's make our table, except we have to choose a little bit different values for this one because there's something different going on here. So normally I want to choose 1 and the base. Now first of all, the base is missing, so that's a base 10. Now the second thing is, if I plug 1 into here, if I choose 1, 1 plus 8 is 9, that doesn't make a really good log value. So 1 doesn't work. So what I really want is I want the x plus 8, what's inside of the log, I want that to equal 1. And I also want what's inside the log to equal the base, which is 10. So what would x plus what will give you x plus 8 equals 1, solve that. So minus the 8 over, so x equals negative 7. So that is what I want to plug in, is negative 7 minus the 8 in here. I get x equals 2 and 2. That's kind of tricky, but what you have to realize, again, is these two values are what are going to make nice, clean numbers. You'll see in a second why. Remember there's a 2 in front of the log. So we're going to plug this into the log and multiply by 2. So I'm going to go 2 times whatever I get in the log for both of these. Now what are we getting in the log? Let's see. This is going to be log base 10. And what do we have in the parenthesis? Well, we put -7. What's -7 plus 8? That is 1, which was what we're looking for. And for the other one, I have log base 10. And what's going to go inside? Well, remember, 2 plus 8 is 10. Okay, so I have 10. And if you think about these, this is saying 10 to the what power is 1? Oh, that would be 0. And this one is saying, the second one is saying 10 to the what power is 10? And that would be 1. So that would be 0 there, that would be 1. Because the log value right here is 0, and you're going to multiply by 2. The log value is 1, you multiply by 2. So what we have here is 2 times 0 is still 0, and 2 times 1 is 2. So we now have a coordinate -7, 0, and 2, 2. So let's plot those dots. We have -7, 0, so -7, 0, and we have 2, 2, so 2, 2. Now, I have 2 dots, but don't we have an asymptote? Normally the asymptote is right here on the y-axis. But this has been shifted. If you remember h, the opposite of 8 is -8, so this got shifted -8 over. So really what's happening is I have an asymptote 8 over to the left. So there's my asymptote. Okay, and so my graph would be up against that, hit right there, turn, and there I go. That would be the equation, or the graph, for this equation. Asymptote again got moved over 8, and I got my nice 2 values. You could find more values. You can always find more values, but use the 2 easiest ones. Oh, we also almost forgot. What is the asymptote? Well, the asymptote is there at -8, and the x value is -8 there. So my asymptote is x equals -8. Because again, the asymptote is when x is -8. Vertical asymptotes like this are always going to be x equals. Horizontal would be y equals. So to graph this one, this logarithm, you might not realize it's a log, but that ln means it's base e. So that's really log base e, so my lower base down here is really an e. The -3 in front means it's going to be stretched and upside down, and the +6 here means it's going to be pushed up. So let's make some values, put some values into a table to graph this. So my values are always going to be 1 and the base. Well, 1 is a good one, so I could put 1 right here, that'll work. But what's the base? What did we say the base was? It was e. So my other one is weird, it's a number, it's e. And e, just as a reminder, is about 2.71-ish. Just if you want to write that in, it helps. E is about 2.71. It'll help later, just in case, but it's about 2.7 something. So I want to now find the value so I can graph. So I'm going to plug in 1. So this is log base e, 1 equals what? ln is log base e. I'm just writing as that because it's easier to kind of see. So what would that equal? Well, what this is saying is, it's saying e to the what power is 1. And if you think about that, are you okay? That would be 0. Anything to the 0 is 1. So hopefully you're okay. This is going to be, oh, isn't it -3 times something? I forgot about that. Isn't there -3 in front? And isn't there going to be a +6? I got to squeeze that in. Are you guys okay with that +6 right there? Because according to the problem, aren't we going to multiply by -3 and add a 6 in the end? And what's here is going to be the answer of that. So we're going to put a 0 right there. Again, let me repeat that. We're going to go -3 times whatever this log gives us, and then add 6. So if we do the math there, what do we get? What's -3 times 0? That's 0. 0 plus 6 is 6. So are we okay? That's going to be a 6 right here. Okay, the next piece, I have, okay, this is going to be log base e equals what? So that's saying e to the what power is e?
1.
Isn't that 1? So this is going to be a 1. So I have negative 3 times something plus 6. And that something, wasn't it 1? Wasn't the log value 1? Again, the log value ends up being 1, so that 1 replaces the log part, the natural log. So what's negative 3 times 1 is negative 3. Plus 6, isn't that going to be positive 3? So now we're going to plot these dots. It's a little weird when you have ln's, but watch how the dots go. I can plot 1, 6. It's pretty clean. Instead of putting e, could you put 2.73? Watch how I plot that. 1, 6, okay, over 1, up 6, so I have a dot right there. 2.73, well, can I go over 2.7, which is right about there? And then go up 3. It's okay to put 2.7, it's a sketch. We're not making perfect graph. So you just kind of go, okay, 2.7, 3. Do you guys remember there's an asymptote on these? Since there's no left or right shift, hopefully you're okay with, there's an asymptote chilling right here at the y-axis. Just chilling. All right. And the asymptote means your graph is going to have that look right there. So our graph is going to go up next to that asymptote, hit this, hit that dot, and start curving. That right there would be your log graph. You have 2 dots, your asymptote, and we got it. Now we forgot this statement right here. Each of these problems have a little statement we're going to talk about when we're done. Your domain are what x values are possible. Well, if your domain, well, are you okay that we can't have 0, right? 0 is an edge. And we don't have no negatives. We have no graph over here in the negatives. So doesn't our graph start from 0 and go forever this way? Now, 0 is not part of the graph. So our domain would be from 0 to infinity, but with parentheses, not brackets, because 0 is not part of the answer. It's just the edge of the answer. So we don't bracket it, we parentheses it. And we can't close infinity in. For this problem right here, we're solving by graphing. So what you have to realize when you solve by graphing is we're graphing this function and that function. Okay? So, first of all, if I want to graph this function, are you okay that graph is y equals negative 1? Is that a pretty easy graph, hopefully? Can you draw a graph through y is negative 1? Can you simply graph that? That right there is y equals negative 1. Boom. We graphed half of it. Woo! Now we got to graph the other side. So we also have to graph y equals log base 2 x plus 6 minus 2. So we have to graph this one now. And in order to graph that one, don't we need to make our table like usual to find 2 good values? Now, it's a little bit trickier here. To graph this, we need to find 2 good values. Now, because of the h shift, we can't just use 1 and the base. We have to find out what would make 1 in the base. So for this one, what we get here, let's see, we have, well, what plus 6 gives you 1, and what plus 6 gives you the base. And the base was 2, correct? So we're trying to make the inside 1 and the base, so 1 and 2. So can we solve that? Can we minus the 6 over? So negative 5 would be a good value to plug in. And if we minus the 6 over here, we get negative 4. So my 2 values I want to plug in are negative 5 and negative 4. You can plug other values in, but they're going to be bad, like crunching-wise. They're not going to be very pretty. Okay, so when we plug in negative 5, are we going to get a value for this, and then aren't we going to subtract 2? So what we're going to do here is we're going to find a value for the log and then subtract 2 for both of these. So we've got to find the value for the log and then subtract 2. Okay, how do you get the value of the log? Well, it's saying log base 2 what? Well, when we plug in negative 5, what's negative 5 plus 6? Isn't that 1? Won't that be a 1 right there? Again, when you plug in negative 5 plus 6 is 1. So when what's the value? 2 to the what power is 1? 2 to the what power is 1. Isn't that 0? Isn't that going to be 0? So can we put a 0 right there? Okay, the other one, 2, log base 2. Let's see, what do we do here? Well, when we put negative 4 in, negative 4 plus 6 is, negative 4 plus 6, doesn't matter which one we're looking at. Isn't that 2? And that's saying 2 to the what power is 2. 2 to the what power is 2. Isn't that 1? Okay. So now, what's 0 minus 2? Isn't that going to be negative 2 here? And what's 1 minus 2? Negative 1. So do we have a coordinate, or two coordinates?
Yeah.
Yeah, we have negative 5, negative 2, and negative 4, negative 1. We have our two dots. Remember, you had to kind of do some adjustments to find them. But let's find these two dots. Let's see, let's put them on. So negative 5, negative 2, negative 5, negative 2, and negative 4, negative 1. I have those two dots. Now, don't we need an asymptote somewhere? Do you guys remember the asymptote's normally the y-axis, but what this say, doesn't this say we shifted it left 6, the opposite 6? So isn't the asymptote was here, but now isn't it negative 6? So we actually have an asymptote here at negative 6. Do you see a graph? Comes up next to the asymptote, hits the line, and turns. So we just got our graph. And we also have the green graph. Okay? And aren't we asking where the two graphs are equal? Isn't where they're equal where they cross? Isn't it right here? So isn't that what we're looking for? So what does x equal? At what x value do they cross? Isn't that at negative 4? So my answer is negative 4. I just solved it. Now, be aware, you could not solve this. I haven't taught you how to solve logs, but you can graphically. You can do it with a graph, but you can't do it. I've never taught you how to solve log. It's, oh, I can't do that, but you can with a graph. By graphing both, seeing where they cross, you can solve them. Now, I want to highlight one thing just in general for this whole entire section. Did you notice we're always putting 1 in the base in? 1 in the base, or what makes it 1 in the base. Did you notice what 1 in the base always get as answers? Do you notice that 1 always gets a 0 out, and the base always gets 1 out? Did you catch that? When you put in 1, or it made 1, don't you always get 0 and 1 on these answers? Watch that. If you choose good values, the answers are always 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. You kind of get used to it. Okay? It's helpful to look at that, look through your notes, and see that when you choose good values, the results are always 0 and 1.